So this is the second of 3 videos looking at the topic of simplifying expressions in algebra. In this video we're focusing on simplifying by multiplying and simplifying by dividing. So let's start off with a question. Simplify the expression x times x. Now I think what we'll do is we'll start this off by giving the wrong answer. The reason I'm doing this is because it's a really common thing to hear. It's a really common confusion. People very often in answer to that will say that's 2x. Let me stress, that's wrong. But I want to think about why people do that briefly, and I also want to think about how we can know that that can't possibly be the right answer. Well, why do people do that? It's because they get it mixed up with adding, subtracting. People often think of x times x, they get it mixed up with x plus x. That would be 2x. That's why I've made a third video, which you'll find linked below, which talks about the confusions between adding, subtracting on the one hand and multiplying and dividing on the other. It's a very common theme in maths generally. But in this particular case here, how can I know that that can't be true? Well, I know it can't be true because I can think of a counter example. What do I mean by that? Well, I'm going to think of a number. I'm going to think of number 7. Now what we're saying here is that when you take a number and you multiply it by itself, you always get the same as if you do 2 times that number. That's what we're saying if we say x times x equals 2x. And I'm going to think of the number 7. And I'm going to say, okay, 7 times 7 equals 2 times 7. See, if this is true, it's true for all numbers. But it's not true for 7. 7 times 7 is not the same as 2 times 7, which means this rule can't be true. X times x can't be 2 times x. So what I want you to think about when you're doing algebra and you're trying to remember what's this rule here and what was I told here and I can't quite remember what I'm doing, try and think about, does this always hold? Is this always the case? If you can find any example where something doesn't work, you know you've got the rule wrong. So it's not that. When you multiply a number by itself, we don't say that's times 2, we say that's squared. So x times x is x squared. What about x times x times x? So that's 3 x's in a row being multiplied together. Well, that would be x cubed. Okay, what about x times x times x times x? That's 4 x's being multiplied. So x times x times x times x. We don't have a special word for that, but when you've got 4 of something being multiplied, we say that is x, or that thing to the power of 4. And so on. 100 x's in a row being multiplied together would be x to the power of 100. Okay, what about something like x times y? Well, there's not a huge amount we can do here. We can't massively simplify that, but we can do one little thing. In maths and algebra particularly, multiply is often invisible. We don't need it. If you see x, y, we can read that as x times y. So when you've got 2 things being multiplied, if they're different unknowns, different letters if you like, just stick them next to each other without the times sign. So a times b would be ab, or p times q times r would be p q r. Just stick them together. What about if you had y times x? Well, if you had y times x, you could say that's yx. In a GCSE exam, you'll sometimes, usually will get away with that, but it's not generally the way it's written. Mathematicians have a little convention, like a way of doing things. They prefer to put things in alphabetical order. So y times x, you could write as yx. It's probably better to write as xy. You may not lose marks, but if you get in that habit of doing that, it probably will save you a few mistakes in the future. Right, so there we go. So that's how we simplify expressions by multiplying. We just, if we count the number of times we see that thing, that becomes the power. Right, a few more examples to do, but I'll clear the board off, so I'll be back in a second. Okay, so 3 more examples here. X times y, first of all. Well, x times x would be x squared. Then we could write x squared times y, but again, we don't need that times sign. So we could just write that as x squared y. The second one here, x times y times y. Well, y times y is y squared, so we're really doing x times y squared. But again, we don't need that times sign, so we can write it like that. Notice these are not the same thing. They look in some ways very similar. We've got an x, we've got a y, and a y, we've got a squared sign, but it's a different thing that's being squared, so we're going to get that's a completely different expression. The last one we've got here, x times x times x times y times y. Well, I've got 1, 2, 3 x's, that's x cubed. So 3 x's being multiplied, I should say, that's x cubed. And I've got 2 y's being multiplied, that's y squared. And again, we don't need the times sign there, so that gives us x cubed y squared. So let's now look at this expression here, 5x times 2x. What can I do in this situation here? Well, first of all, what's different? Well, I've got differences. I've got a 5 and I've got a 2. I've got numbers appearing in front of the unknowns, in front of the x's. Okay, so what am I going to do about this? Well, first of all, let me give you a little explanation and then I'll give you a rule. 5 times x, 5x. And 2 times x, 2x. I'm just going to write this out longhand for a second. I've got a time sign in between those here like that. Now I want you to remember that when you're multiplying two numbers, the order doesn't matter. You can do it in whichever way around you want to do it. So when you're learning your times tables, for example, if you know that 8 times 9 is 72, then you also know that 9 times 8 is 72. The order doesn't matter. So I could happily take this, this expression here and I could turn this round and make that 5 times 2 times x times x. Right, well, let's see what we can do. 5 times 2, that's 10. And x times x is x squared. And again, I don't need a little time sign in because times in maths is usually invisible. So 5x times 2x is 10x squared. Now let me stress, you don't need to write this out like this every single time you do one of these questions at all. It's totally unnecessary. What you need to do here then is just know a little rule, if you like, which is this. If you've got numbers appearing in front of the x's, like the 5 and the 2 here, multiply the numbers, 5 times 2 is 10, and then multiply the x's, x times x is x squared. So 5 times 2 is 10, x times x, x squared. Let's try another one. If I've got, say, 4y times 3y, then that would be, well, 4 times 3 would be 12, and y times y would be y squared. So notice here I didn't write this all out the second time round. That's just a little bit of explanation to help you understand, where that's coming from. It's not just a rule someone invented one day. Quickly look at another couple of examples. What if we had 4x times 3y? Well, again, I can do 4 times 3 is 12. And x times y, again, not a huge amount I can do there, but I can at least put them next to each other. X times y is xy, and again, I don't need a times sign here because times is invisible. So 4x times 3y is 12xy. What about if I had this one here, 5x times x? This often causes confusions because people go, well, they've learnt this rule here for multiply the numbers, but there is no number here. But what number would that be? If you had to write a number there, what would it be? Well, it would actually be a 1. I said in the previous video, 1 in maths is the invisible number. It's a number that's frequently not written. The moment you write that, I think this becomes much, much easier. 5 times 1 is 5, and x times x is x squared. In a test, in an exam, the examiner is not going to care if you amend the question by sticking a 1 in front of that. said in the previous example, I think, that they, previous video, they know the answers. They're not checking whether you've annotated the question. All they care about is whether you put the answer as 5x squared here. So if you want to put the 1 in, that's okay. The one situation you mustn't put a 1 in is when you're writing an answer, because that can actually invalidate it. That can cause you to lose marks. But if you're just amending a question, that's kind of okay. Eventually you should get to the point where you don't need to do that, but if it helps, so be it. At least mentally be thinking of this 1 here. 5 times 1 is 5. So now we've made things a little bit more complicated. Now we've got an x squared times x cubed. We're using powers in the question. And again, I'll give you a little explanation and then I'll give you a rule. So first of all, let's think what x squared is. X squared is really just x times x. And x cubed is just x times x times x. So all I've done is I've taken this x squared here and I've written it like that. And I've taken the x cubed and I've written it like that. And what am I doing with these two terms? Well, I'm multiplying them. So what have I got here? Well, I've got 1, 2, 3, 4, 5 x's, which is x to the power of 5. Now again, you may well be able to spot a rule straight away here, which is that when you're multiplying powers of something, as long as it's the same thing, you just add the powers together. So x squared times x cubed is x to the power of 5. You don't need to write all this out. I hope it helps to understand where that rule comes from. A very common wrong answer here is people go 2 times 3 is 6. But when you're multiplying powers of the same thing, you add the powers together. Let's look at a couple more examples. So I'll try y to the power of 3 times y to the power of 7. Now here it would be a little bit tedious to write all those y's out, and we don't need to. We've got 3 y's being multiplied by another 7 y's being multiplied. Well, that will be y to the power of 10. Just add the 3 and the 7. Okay, what about this one here? X to the power of 5 times x. That can throw people. Again, that can be difficult to spot. Why? Because there's no number here. But there is a number there. What number is that? Well, the one number that we frequently don't write, is 1. X means x to the power of 1. It's not necessary to write the 1, but it's still there. The moment you put that in, it becomes much more obvious what to do with that rule. X to the power of 5 times x to the power of 1 is x to the power of 6. So again, invisible ones often cause problems. Something just to be aware of. If you see a gap there where you think, oh, I wish there was a number there, it's probably the number 1. Okay, so 3 more questions to finish off this section of multiplication. Right, so first one here, 7x squared times 2x to the 6. Okay, well, again, I know my rule, which is multiply the numbers. 7 times 2 is 14. X squared times x to the 6. Well, again, we've got multiplying powers of the same thing, x squared, x6, so we're going to add the powers together. 2 plus 6 makes 8. This one here, we've got 14p times minus 2pq. Nothing to be intimidated by with that minus if you know your rule for multiplying negatives. A positive times a negative is a negative. So 14 times minus 2 is minus 28. P times p is p squared, and we've got a q in there as well. Final question here, 8x squared times x to the 4. Okay, so we've got that same problem here. There's no number written here. Well, I'm just going to stick a number in. I'm going to put in there that invisible 1. It was always there. I haven't changed the question, but I've just written it in to make it easier to understand what I'm going to do next. 8 times 1 is 8. X squared times x to the 4 is x to the power of 6. Now I'm just going to briefly mention a way in which we can adapt that kind of question we've been looking at, something that's slightly different and that often throws people. Let's look at this question here. It says simplify 4 squared times 4 cubed. Now it's possible to work that out, to work out 4 squared, work out 4 cubed and multiply those together. but it's also possible to write them as a power of 4. And it's the same rule that applies what we saw with x's. What we do, if we're multiplying powers of the same thing, then we add the powers together. So 4 squared plus 4 cubed. Well, let's write this out longhand. 4 squared is 4 times 4. 4 cubed is 4 times 4 times 4. We're multiplying those together. So what have we got? We've got 1, 2, 3, 4, 5 fours. That is 4 to the power of 5. It's very common to find that people remember this bit here. They remember the rule, add to 2 and 3 makes 5, and you often see people put 16 to the power of 5. I think it's just because it's very tempting. When you see a 4 times 4, it's hard to stop your brain from just automatically jumping to do that calculation. If you write it out longhand, you can see there is no 16 in this sum whatsoever. It's we've just got 5 fours being multiplied. That's 4 to the power of 5. Let's try another one. Let's go for 7 to the power of 6 times 7 to the power of 2. Well, again, as we said before with x's or y's, you don't actually need to write it out each time. The rule is if you're multiplying powers of the same thing, which we are, 7 times 7, 7 to 6 times 7 to the 2, then we add the powers together. So that's 7 to the power of 6 plus 2 makes 8. Maybe do one more, 3 to the power of 10 times 3. A little bit of an issue with this one because we don't have a number here, but we do. It's just invisible. That's the number 1. So here, that would be 3 to the power of 1, and we're multiplying powers of the same thing, so we add the powers together. So that would be 3 to the power of 10 plus 1 makes 11. Now, that only works if we have the same base. So if you saw a question like this, there's nothing you can do. I mean, you can work that out as a sum. You work out what 5 to the power of 4 is, work out what 2 to the power of 3 is, and find the answer, probably using a calculator, but you can't write that as a simplified power of anything. There can be cases where you can do a little bit more when you've got different numbers here, but that's definitely higher tier rather than foundation tier. So if you're doing the foundation tier exam, you're never going to see those questions. At some point in the future, I'll make a video on the higher tier ones, but again, for the most part, everything we've looked at so far could be on the foundation tier. That won't. So now we've got something that's a little bit different. Here we've got x to the 5, but the whole thing is being raised to the power of 2. So that's not the same as that. That would be x to the power of 7. Multiplying powers of the same thing, add the powers together. This is not the same question. This is saying square the x to the power of 5. Now, in a second, I'll give you a rule, but before I do that, let's just see if we can work out where that rule comes from. If you know where rules come from, it usually makes it easier to remember those rules. So, first of all, I want you to remember that squared means multiply something by itself. So here, x to the 5 squared means x to the 5 times x to the 5. What would that be? Well, we've got, now we're multiplying powers of the same thing, we add the powers together. Gives us x to the power of 10. Let's try another one. Again, the rule is coming, but let's do this first of all. So x to the 4 all cubed. Okay, so that means x to the 4 times x to the 4 times x to the 4. And we are multiplying powers of the same thing, so again the rule is you add the powers together. 4 plus 4 plus 4 is x to the power of 12. Now hopefully from that you can see a rule. We've got x to the 5 squared is x to the 10, or x to the 4 to the power of 3 is x to the 12. What are we doing there? Well, what we're doing there is we're multiplying those together. So there's the rule. When you're raising a power to a power, you multiply the powers. Again, if you can't see that, so I didn't spot that, don't worry, that's fine. Let's just do a couple more examples and it'll become much more obvious. So let's see, x to the power of 7 to the power of 4. So we're raising x to the power of 7 itself to the power of 4. So again, we multiply the powers together. That will be x to the power of 7 times 4 is 28. Try another one, x to the power of 6 to the power of 10. Again, we're raising a power to a power, so we multiply the powers. That's x to the power of 60. Again, I should stress on the higher tier paper, this can definitely get more complicated, but on the foundation tier paper, that's really about as hard as it gets. So we're going to leave it there for now. So the last thing we're going to look at today is dividing powers of the same thing. So example would be this question here, x to the power of 8 divided by x squared. Now again, I'll give you a rule. If you just give me a couple of minutes, I will give you a rule, but let's try and see where that rule comes from. So here's what we're going to do. I want you to remember that divide, or division signs, are just another way of saying fractions. So x to the power of 8 divided by x squared is the same thing as x times x times x times x times x times x times x. That's 1, 2, 3, 4, 5, 6, 7, and one more, all over x times x. That's the same thing. 8x's on the top being multiplied, 2x's on the bottom being multiplied. And a rule with fractions is that whatever you divide the top by, if you divide the bottom by the same thing, you get the same fraction. For example, if we had the fraction, let's say 6 over 12, I could say, well, I've got, those numbers can both be divided by 6. That would be 1 over 2. Or if I had the fraction, for example, 9 over, what should we say, 9 over 15, they can both be divided by 3, which gives me 3 over 5. So wherever you divide the top by, if you divide the bottom by that same number, you get the same fraction. These are equivalent fractions. 6 over 12 is a half, 9 over 15 is 3/5. You can do just the same thing here. We could divide top by x, which cancels one of the times x's. We could divide the bottom by x. We could do the same again, like that. What does that leave us with? It leaves us on the top with 6x's being multiplied, or x to the power of 6. Now again, I'm conscious that's a bit of a long-winded, waffly explanation. So for those of you who just want, give me the rule, well, here's the rule. If you are dividing powers of the same thing, you subtract the powers. So 8 minus 2 will be 6. So x to the 8 divided by x squared is x to the power of 6. I did want to mention this fraction thing though, particularly because you quite often see they give the question not as a divide like that, but typically like that. That's the same kind of question. That divide there, that fractions line, sorry, is a divide symbol. So the answer for that one will be x to the power of 6. That's about as hard as they get again on the foundation tier. There's a whole load of other stuff on the higher tier that I will cover at some point, but that pretty much gives you all you need to know in terms of the basic rules for powers. One little thing to mention before we finish off, but that's a 1-minute job and then we'll be done for today. Now, one question that you sometimes see in GCSE foundation tier exams is this one here. Simplify the expression x to the power of 0. Now, I have a problem with this question, and the problem is that I can tell you the answer. In fact, I'll do it now. The answer is 1. What is going on there? That's a different story. There's a whole load of stuff there to understand. First of all, how can you have to the power of 0? That's no x is being multiplied. That doesn't make any sense, does it? And why is it 1? But frankly, for foundation tier GCSE, you don't need to understand why that is. And I hate saying that because I would always rather that the students get what's going on. So here's what I'm going to do. If you just want to learn that, that's fine. What I'll do, rather than clog up this video with any more stuff, because I've probably talked enough for today, what I'm going to do is record another video where I give a couple of different explanations as to why that is. So if you want to watch that, you can. If you're the kind of person who wants to see why the things work the way they work, you can. But if you're happy just to have someone tell you that, that's fine too. Right, so don't forget to watch the third video, which looks at the potential confusion between adding, subtracting on the one hand, multiplying and dividing on the other. That will be a useful thing that hopefully will help avoid any kind of mistakes, confusions between those two different kinds of questions. And that's all for today, so I will see you soon.